Alright guys, today we're going to learn how to draw atoms. The first energy level holds 2 electrons, the second holds 8, and the third holds 18, with 8 available for bonding. Our first atom we're going to look at is hydrogen. And if you notice on the periodic table, hydrogen's right here, and it has an atomic number of 1. And the atomic number is also the number of protons. So you go down here, since the atomic number is 1, you will put 1. Number of electrons will also be 1 because this atom is neutral, meaning it has an equal number of charges, positive and negative. So protons and electrons would be the same. For neutrons, it's a little different. You have to take the atomic mass, which is 1.008, and round it to the nearest whole number. So it'd be 1, and subtract that from the atomic number. So 1 minus 1 would be 0. So an atom of hydrogen has 1 proton, 1 electron, and 0 neutrons. We'll come back to valence. So in the nucleus, you have protons and neutrons. And we have 1 proton and 0 neutrons. The electrons go around the nucleus in energy levels. The first energy level can hold a maximum of 2 electrons, and we only have 1, so we'll just put that 1 in the first energy level. And valence electrons just mean the electrons found in the outermost energy level. And the outermost energy level is the only energy level we have, which is the first one, and it only has 1 electron in it. So that counts as our 1 valence electron. Moving over to oxygen. Oxygen on the periodic table has the atomic number of 8. So that means it has 8 protons. And since they're neutral, it also has 8 electrons. And for neutrons, you're going to take the atomic mass and round it. 15.999 rounds to 16. So 16 minus 8 would give you 8. So now you go up here and you're going to put your protons and your neutrons in the nucleus. So we have 8 protons and 8 neutrons. For the electrons, you can go back up to your key up here. You'll see that 2 of your electrons can fit in the first energy level. So we'll go ahead and draw those. So there's our first 2. Now, do we only have 2 electrons here? No, we have 8. So we need to place the other ones around that. So only 2 can fit in the first energy level. So 8 minus 2 would be 6. So we have 6 more. Can those 6 fit in the second energy level? Yes. So we'll go ahead and draw them. 1, 2, 3, 4, 5, 6. So now altogether we have 8 electrons for our oxygen atom. So we have 2 in the first energy level and 6 in the second. 6 plus 2 gives you 8. Now for valence, we have a lot more electrons now, and the farthest energy level from the nucleus would be the second energy level. So I'm going to highlight those electrons because they're in the farthest energy level away from the nucleus, and that means we have 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay, let's go to sodium. You find sodium on the periodic table. Na, right here, has an atomic number of 11. So that means you have 11 protons, 11 electrons, and for the neutrons you subtract. So you'll do the atomic mass rounded, which is 23 minus 11, which gives you 12. So let's go up here and put our protons and neutrons in the nucleus. And so you have 11 protons, 12 neutrons, and now you need to place the electrons. So the first 2 go in the first energy level, and then you need to fit the other ones. They need to move up to the next energy level. So the second energy level can hold a maximum of 8. So go ahead and put your 8 in there. 2, 3, 4, 5, 6, 7, 8. Okay, so 8 plus 2 gives you 10. Do we only have 10 electrons? No, we have 11. Can we fit another one in the second energy level when it only holds 8? No, we cannot. We have to move it up to the third energy level. So 10 minus 11 would give us 1 because we have one more to place. So we'll put that in the third energy level. So let's count our electrons. 1, 2 in the first energy level, 8 in the second, which makes 10 altogether, and then one more in the third, which makes 11 electrons. So for our valence electrons, these are the electrons in the outermost energy level. This time we have a third energy level that has an electron in it, so we just count the ones in that one. And there's just one in the third energy level, so we only have one valence electron.